Every piece of software begins as an abstract human idea. A client looks at a bottleneck in their business and says, "We need an online food delivery app." That single sentence sounds simple, but it conceals significant technical complexity. Hidden within that request are thousands of unstated database structures, logical dependencies, and conflicting user desires. To translate that idea into a functional product, engineers use a structured framework, the Software Development Cycle, or SDLC. It organizes the development process into 7 distinct phases: requirement gathering, analysis, design, coding, testing, deployment, and maintenance. To see how this works in practice, we are going to walk through the development of a real-world project, a complete college management system. Without the structure of the SDLC, engineering efforts risk collapsing under the weight of unorganized client demands before the first line of code is ever written. The process starts with Phase 1, requirement gathering. Before developers can decide how to build the software, they must identify exactly what the software needs to do. For our college system, we start by collecting categories of information: student records, faculty records, attendance, fees, and exams. These inputs lead to Phase 2, requirement analysis. Raw human requirements are rarely perfect and often contain logical gaps or contradictory requests. Developers audit if requests, resolving conflicts and prioritizing essential systems over secondary features to create a clear project scope. The final output of this analysis is the Software Requirement Specification, or SRS document. The SRS acts as the final blueprint. It is a formal agreement between the client and the engineering team, documenting exactly what functions the system must perform. Moving forward without a finalized SRS is a primary cause of project failure. A stable system cannot exist without a specific, documented definition of its intended behavior. Once the requirements are set, we enter Phase 3, software design. We move from the what to the how, planning the architectural logic that will support the software. The SRS is translated into technical structures. For the college system, developers map out the central database and connect it to specific modules for students, faculty, fees, and exams. With the design complete, the team moves to Phase 4, coding. This is the moment abstract plans are converted into executable code. Every feature requires specific instructions. To build an authentication sequence, the program must first retrieve a user's password. Next, developers write conditional logic to verify that input against a stored credential. Only when that condition is met will the system execute the login function. This process of logical translation happens for every single feature originally outlined in the SRS document. Coding is the fine translation, taking human requirements and architectural blueprints and turning them into specific machine instructions. Phase 5 focuses on testing. Far from being a simple search for bugs, this is a structured hierarchy designed to verify the system at every level of its construction. Level 1 is unit testing. Developers isolate and check the smallest pieces of code, like the specific login function we just wrote. Level 2 is integration testing. Engineers check how separate units communicate with each other, ensuring the student module exchanges data correctly with the exam module. Level 3 is system testing, evaluating the entire integrated college management framework as a single operating entity. Finally, acceptance testing. This is where real users interact with the system to verify it solves the problems identified at the start of the project. Throughout these levels, engineers use 2 different approaches: black box and white box testing. Black box testing checks functionality and outputs from a user's perspective, while white box testing audits the internal code structure directly. This layered verification ensures the final software fulfills the technical requirements outlined in the SRS without failing in a live environment. Phase 6 is deployment. The software is finally installed on the college servers and made available to real-world users. But the work continues in Phase 7, maintenance. Software requires ongoing security patches, bug fixes, and new updates, such as adding a mobile app for students. This brings us to a common question regarding process models like Agile, Waterfall, and Spiral. But do these models replace the SDLC? They do not. They simply dictate the strategy used to execute the same 7 phases of the life cycle. The waterfall approach is a rigid strategy. You complete one phase entirely before moving to the next, with no overlap between them. The prototype approach prioritizes early feedback, running through the phases quickly to build a visual model that the client can review before the final version is built. The spiral approach loops through the phases repeatedly, using each iteration to identify and mitigate technical risks. Managers can change the pace or the order of the workflow, but the essential functions of the 7-stage lifecycle remain the same. So, which single stage of development pipeline is the most important? There is no single most important stage, because each phase is structurally dependent on the ones that came before it. This is the formula for successful engineering. High-quality software is the sum of clear requirements, good design, clean coding, proper testing, and continuous maintenance. If the requirements are flawed at the start, the engineers will end up building the wrong software. If the architectural design is poor, it becomes difficult to write clean, efficient code. Weak coding leads to bugs, and poor maintenance leads to the eventual failure of the system. Every developer must understand this sequence. An idea leads to requirements, which lead to an SRS, which dictates the design, which guides the coding, followed by testing, deployment, and maintenance. Software quality isn't achieved by focusing on just one phase. It requires executing every part of the lifecycle with consistency and rigor.